Now I know you're just chomping at the bit for this. Why? Why is there this transition between the dominance of conifers, evergreen conifers, and evergreen broadleaf species? Please, how does this happen? Right? Yeah. All jokes aside, if you've driven from California to Oregon, or much less if you've just driven from, say, SLO to Santa Cruz, if you've been to Swanton, or if you've driven from the south to, say, Humboldt County, you've seen this transition. The transition from dominant broadleaved evergreen species like most of our oaks to conifers. This is a transition that happens at a regional scale between California and the Pacific Northwest, and it's driven by variation in temperature and precipitation. The cooler climate and dominant higher amounts and dominant winter precipitation, higher amounts and winter precipitation distribution of precipitation in the Pacific Northwest leads to the dominance of conifers. They are favored over broadleaf oaks when you have that condition. Cooler, wetter overall, but still most of the precipitation is in the winter. There, I said it better that time. And I just want to kind of, having just talked about the Mediterranean forests, I want to just point out that the distribution of forests where most of the precipitation occurs in the winter is broader than Mediterranean forests overall. So you can take this map and you can compare it to the map of Mediterranean forests, and you're going to find that there's more forests that meet those conditions than strict Mediterranean forests. So Oregon can have some summer precipitation. The Ethiopian plateaus also can have some summer precipitation, and they don't quite meet the definition of Mediterranean, but they have some similarities. And these places, in a lot of these places, you can see this transition to dominance of conifers. As I mentioned, Humboldt County is one of those places. Drive up into Humboldt County, and you're going to leave the land of coast live oak. You will leave them behind in southern Mendocino County, and you won't see them again outside of an arboretum. Lots of winter precipitation, cooler overall. Somewhere in Humboldt County or north of Salt Point State Park in Sonoma County, one enters the Pacific Northwest, where conifers dominate, where you have dominant ponderosa pine in the highlands, or Douglas fir in most of the region, and also redwood dominating on the coast. Again, just transition to the dominance of these conifers. Once you get into Oregon, even more conifers, even more much higher productivity. Coastal Oregon and Washington are really great for growing Douglas fir and some other conifer species. Douglas fir is the one with the highest economic value. There are some hardwoods within this, but they tend to be associated with disturbed areas or riparian areas, such as alder. Highly productive, very important forests, but they are really restricted to the area that's wet and cool. As soon as you get to the east of the mountains, this all changes over and you lose a lot of these forests. Here's a little bit clearer picture of this. You can see the alders better here. This kind of transition doesn't just happen north to south, it also happens from the west to the east as one goes up into the Sierra Nevadas. And it's the same drivers. Please allow me to illustrate this just one more time with another example. It's the same drivers: precipitation amounts and temperature. Now, the Sierra Nevada, particularly the southern Nevada, is notable for these this really extreme increase in elevation from about 100 feet to 14,000 feet. There are some really deep canyons, narrow canyons, such as illustrated here. This is the entrance to the South Fork of the Kern, or excuse me, to the Kern River. And that's the South Fork of the Kern River. This gate-like entrance here is right outside of Bakersfield. It's pretty cool to drive towards the mountains and you get to see this narrow entrance to it. But go up into this area and you're going to find the same transition. Actually go up within these deep canyons, go up from these deep canyons, you're going to find the same transition. So what is that? Well, as one goes from the west to the east, conditions become cooler and wetter, and you see a transition from dominance of broadleaved, sometimes evergreen hardwood species to conifers. This creates a slow transition from broadleaf to evergreen dominance as one goes up in elevation. So in the low elevations, there's lots of shrubs and broadleaf species and some conifers that are adapted to those hot, dry conditions. That's what you're seeing here. These are the lowland forests, gray pine, manzanita, that sort of thing. As one goes up, say, to Yosemite Valley, you start to have dominance of evergreen broadleaf species, especially on north slopes, on the cooler slopes, the north slopes, which are more protected from solar radiation. The conifers increase in dominance. On the south-facing slopes, which intercept more solar radiation, they tend to be dominated by conifers broadleaf species by oaks, red oak, or interior live oak. Also some odd conifers like California nutmeg, unique conifers. They're really cool, but they're just unique. Keep going up in elevation, and it becomes just too cold for broadleaf species. And you have high elevation forests, which are dominated by things like sometimes lodgepole pine, ponderosa pine or Jeffrey pine in the highest elevations and driest elevations, or more what I would say are unique conifers, such as limber pine, white bark pine, which I think is really cool, and foxtail pine, associated similar kinds of trees, which are just really specialized to take advantage of these hot or these climates that can be very cold and where all the precipitation it falls in the winter. I slipped there and said hot, but actually this high elevations could be very hot, relatively hot too, and that's something that distinguishes many of these conifers and allows them to be dominant in the Sierra Nevada, but not necessarily do very well outside of it in the further north part of the country, and let's say in Canada, where the winters are much longer, much colder, and the summer temperatures just don't reach the same.